Welcome everyone to our final presentation. My name is Stephen. My colleagues are Dillon, Jonah, and Caleb. We're part of Group 9. Our project is the Pickup Wheelchair Lift. On today's agenda, we'll be going over the client background, what we have as a design problem, and what we have come up with as a design solution for the client. Going over the client background, our client's name is Robert. He lives in Saskatoon. He lives with Kennedy's disease, which is a disease that causes the weakening of his muscles over time, which causes him to have limited mobility. He currently gets around in his Chevy Tahoe SUV with a wheelchair lift. Due to his progressive nature of his condition, he is unable to walk from the rear, where the lift is located, to the driver's seat, which is why he's looking for a new lift for his 90 Chevy short box truck.
This brings us to the problem statement as follows. The client's poorly built wheelchair lift no longer accommodates his deteriorating health conditions and has reduced his motor vehicle independence. The current solution has failed, leaving the client in a cold parking lot waiting for assistance. Along with these failures comes a long lead time of the parts and thus a long repair time. None of the market available lifts satisfy the client's needs, as they are all either complete vehicle conversions at a steep cost or crane style lifts that the client has expressed he is not interested in. The control systems will be out of the scope of this project, as the client wishes to take care of this section himself. This brings us to the key objectives. The first is a simplistic design. Following this, locally sourced materials are desired, as they allow the lift components to be purchased and manufactured here in Saskatoon. The ease of use is also important due to the client's limited mobility, along with access to both the driver's and passenger's doors to accommodate for the client's futures. One of the key constraints is the operating space due to being located in the box of a truck. Another is the weight rating due to the rather heavy nature of the client's power wheelchair. Lastly, the cost had to be kept at a reasonable level.
So our final design solution is shown on the right, and we believe that it will allow the client to regain his independence and will serve him not only now, but also in the future. I'll go through the design sections in a moment, but I wanted to highlight some key considerations the group needed to keep in mind when coming up with this product. Firstly, due to the workspace we had to deal with, the design solution needed to be able to move the wheelchair up and down from side to side in the truck box, as well as pivot in and out of the box to ensure proper orientation. So starting with the ramp and working our way into the box, the ramp is quite similar to the client's current design. However, it features additional support bracing on the underside to help with deflection and stress, and it has 4 retractable ratchet straps which aren't shown in the picture. These 4 ratchet straps will secure all 4 corners of the wheelchair during transport to ensure safety. Then we have the telescopic arm, which is one of the most crucial components of the design. It will extend and retract by means of a 12-volt winch line running down the center of the arm. The arm is composed of 5 greased aluminum telescoping sections, which have inner alignment slots to ensure proper tracking. Once the platform has cleared the truck box, due to the arm retracting, the mast rotates by means of a 24-volt gear motor situated under the rolling platform. After this, the roller coaster-inspired rolling platform, which is powered by a combination of a modified winch with a chain drive, moves the assembly laterally until it is centered in the box. At this point, the wheelchair ramp will lower due to the telescoping arm and will be set for travel.
To understand the workspace our solution must operate in, we conducted a motion study shown in this animation. Hopefully it'll help everyone here gain a better understanding of the full range of motion. Once the client secures the wheelchair to the platform, he moves it into his truck via a transfer board and the lift begins operation. The parking lines you can see in the model are in accordance with Saskatoon's accessibility design standards. This ensures the design operates in today's built environment. As mentioned, our design will be installed in a 1993 Chevrolet short box. The truck box is modeled from Chevrolet's 93 technical guide, but with small adjustments, the lift can be installed in other vehicles. As our client's condition progresses, he will eventually lose the ability to drive, so it's essential for us to plan for the future and have the lift be accessible from the passenger side also. Regarding the design safety factor, we consulted the government of Saskatchewan vehicle standard and inspection agencies. This information in trying to minimize the overall weight, we ensured all components met a minimum design safety factor of 2. Regarding the CAD modeling, as no prototype was built, all assemblies were modeled with high attention to detail. For example, all the nuts and bolts were modeled to the correct specifications, allowing us to gain a better understanding of the allowable tolerances. The rolling platform shown is one example of CAD modeling done. From these models, we were able to make drawings, and in total, we delivered 157 drawings to client, which include part, assembly, and fabrication drawings.
We would like to thank you for listening to this presentation, and we'd also like to thank Robert for providing us with such a great capstone project that can truly be used to make a difference in his life, and possibly anyone else in a situation similar to his. This gave the project a personal touch in which the entire group was invested. Thank you.